The alkene 3-methyl-pent-2-ene reacts with hydrogen bromide to form a mixture of 3-bromo-3-methyl-pentane and 2-bromo-3-methyl-pentane. The alkene 3-methyl-pent-2-ene exists in E and Z stereoisomers. So draw the structure. Right, let's get the highlighter on first. So let's try and highlight in fact, I'll use a pen to just underline the carbons in the carbon-carbon double bond. So there's one there and there is one there. And what I'm going to do now is I'm going to highlight the groups in different colours. So on the left-hand carbon, I have a methyl. I also have a hydrogen. And on the right, and I'll do these in different colours, so I also have a methyl on the right, and I have an ethyl. So let's start with the carbon-carbon double bond. So carbon-carbon double bond. So Z, if you remember, means that they're on the same side. So I need to, between the blue and the green that I've highlighted, I need to work out which is my high priority. Well, carbon has an AR of 12 and hydrogen is 1. So this one here is my priority group on the left. So let's put that on here. Don't forget about connectivity. Okay. And then on the right, this is the yellow versus the red. So I've got the methyl versus the ethyl. Now, the carbon directly attached to the carbon in the carbon-carbon double bond both have an AR of 12. So we move along one. The red has another carbon with an AR of 12, whereas the methyl only has hydrogens at a 1, which means the red is the high priority group. And again, be aware of connectivity here. So CH3 down here. So when I talk about connectivity, I'll just kind of draw what is not acceptable here. So what you might draw is this. Now that would be wrong because the bond here is going to this hydrogen here. Okay, so you wouldn't be able to do that. If you did want to keep it at CH3, the bond here has to be pointing to that carbon there. Okay, so that's what I mean by connectivity. Just making sure that we don't lose silly marks when we've got something correct. Okay, part B, name and outline the mechanism for the formation of 3-bromo-3-methylpentane. Right, that's going to be important. We need to make sure that when we do our mechanism, the bromine and the hydrogen go on the correct carbons. From this reaction of 3-methylpent-2-ene with hydrogen bromide. Okay, so let's start with let's do the mechanism and then we'll come back to it all in a minute. So I'm going to start with the carbon-carbon double bond here. Because I'm doing a mechanism, I want to keep everything else out of the way. So let's go back and look at this. So I've got a hydrogen and a methyl. So CH3, H. And on the other side, I've got a CH3 as well. And a CH2, CH3. Okay, now this is reacting with hydrogen bromide. So there's my hydrogen bromide. Okay, and I'll do step one and then we'll talk about it from there. So not that you get marks for this, but a good habit to be in is to put the dipoles on here. So you've got a D plus hydrogen. That's going to be attracted to something with a high electron density or a high area of negative charge. So here's our first arrow from here to here. Now hydrogen can only form one bond, so the pair of electrons in the middle of the hydrogen-bromine bond are going to go to here. It goes to the bromine because the bromine is the most electronegative element. Okay, so just if you forget how to do all of these, okay? So let's draw the intermediate. Now we need to make 3-methylpentane, which means the bromine needs to go on carbon number 3, which is this one, which means that one has to be my carbocation, that my positive charge has to be on there. So H, C, CH3, just copying everything out. as I've got it in step 1, and then I'll do it from there. So this has to be my carbocation for my bromine to go on, which means my hydrogen went on here. If you get it the other way around, you'd lose a mark, maybe 2. Have a look at the mark scheme. When you've done this, I'm just kind of showing you how to do it correctly. We've then got bromide left over with a pair of electrons there. So again, curly arrow from here to the D plus carbon, and then draw my final product at the bottom down here. So HC, CH3, HC. Okay, so marks for this, and I'll do that in a green colour instead. There's a mark for the curly arrow from the carbon-carbon double bond to the D plus hydrogen. The second mark is for a curly arrow from the hydrogen to the bromine. There's a mark for the correctly drawn carbocation, and 1 mark for the curly arrow going from the lone pair on the bromide to the carbocation. Okay. The name of the mechanism, so this is, we've added the HBr to this, so this is going to be addition. And if you look at the reactant, if I just draw a circle around it like this, you can see that the red curly arrow is going to the HBr, which means that that is going to be an electrophile. So this is electrophilic addition, and again there will be a mark for that. So 1, 2, 3, 4, 5 marks so far. So explain why the 3-bromo-3-methyl pentane is formed rather than the other one. Right. So this is, we've got to be quite careful here, because if I get the highlighter on, the carbocation would either be where the yellow highlighted carbon is, or the red one there. So let me put the red one over here, okay? And I'll put the yellow one over there as well. So because it's in the yellow position, if we just concentrate on that yellow carbon that I've drawn here, okay? So I'm counting the number of carbons that is attached to, and again, if I kind of do this in yellow, 1, 2, 3. So this is the tertiary carbocation. So tertiary carbocation. However, if it was on the red one instead, so again, if I count the number of carbons that are attached around the red carbon, there would be 1, 2. So that would be a secondary carbocation. So it's not good enough to just say one carbocation is more stable than the other. You actually have to state which one. So you've got to classify what both of these structures will be. So the tertiary carbocation is more stable than the secondary carbocation. Okay, so that will be one of the marks. Therefore, now we make the 3-bromo, don't we? So therefore, 3-bromo, 3-methyl pentane is formed as this is made, a good word to use here, via, that means through the route, via the tertiary carbocation. Okay, so there's your final 2 marks for that question there.